the day. The topic of the presentation is Prisma-based study of Nidar Ophiolites as Martian analogues for serpentinization. This study has attempted to explore the selected ophiolite terrain of Ladakh, Himalayas, India, using recently acquired hyperspectral data from Prisma mission. This research, carried out in the framework of joint ASI-ISRO Earth Observation Working Group, has characterized the ophiolite section of Ladakh at Nidar region for lithology based on spectral reflectance features and mapped the various lithological units. Introduction of ophiolites. Ophiolites represent a distinct variety of igneous rock. In fact, they are not simply rock but rock assemblages that represent fragments of oceanic crust and underlying mantle. This is a typical ophiolite sequence with depleted mantle peridotites and layered ultramafic and mafic cumulates representing upper mantle, massive gabbro and sheeted dikes representing the moho part, and pillow basalt and deep sea sediments representing the oceanic crust. Petrographically, due to presence of variety of complex rock assemblages, ophiolites have characteristically diverse mineralogy. This is a global map showing the occurrences of ophiolites on the Earth, where they occur associated with collisional orogenic belts and their emplacement events overlapping with the collisional events during assembly and breakup of supercontinents. From Indian subcontinent, ophiolites are found in association with Indian plate margin and occur along the northern margin of Indian plate. Alpine Himalayan ophiolites represents the part of Indo-Sangpo-Suture zone. Here one can see the ophiolites in form of disseminated bodies from Alpine Himalayan range in form of these red that are represented by this red color disseminated slices all along the Indo-Sangpo-Suture zone. Now coming to the significance of ophiolites. Ophiolites, being representative of the mental lithology, serve as an excellent probe to investigate and study deep mental processes. Their economic significance lies in their being the host for podiform chromatites and diamonds. And ophiolites serve as a good analogues for planetary crustal rocks, especially for Martian crust. Mars, like Earth, is a differentiated planet, and its crust is composed of basaltic and ultramafic rocks that represent composition of ophiolite terrains, with composition ranging from mafic to ultramafic rocks as revealed from the Martian meteoroids composition analysis and remote spectral analysis. Serpentine-bearing outcrops have been detected on the Mars from remote sensing studies. These serpentines, which are formed as an alteration products of ultramafic and mafic rock assemblages. So ophiolites with characteristic mineralogies as found on Mars along with associated alteration products at low temperature aqueous alteration result in formation of serpentine minerals are typical of Martian crust. Therefore, study of ophiolite section of the Earth can provide easily accessible as area that can serve as an analog for Martian. Here of the present study is Nidar ophiolite, one of the ophiolite slices of Himalayan Indo-Sangpo-Suture zone, which are located at around 32 to 30 degree north and 78 degree to 79 degree east towards southeast of Ladakh, India. It forms an eye-shade exposures within Nidar Valley, as can be observed in this lens set 8 OLI false color composite image. Nidar ophiolites in this Nidar Valley displays a complete ophiolite sequence with ultramafic rocks at the base overlain by mafic exposures at the middle and followed by volcano-sedimentary rocks at the top. Ophiolite terrains are rare on continents. The Ladakh ophiolite sequence that forms part of Himalayan Indo-Sangpo-Suture zone represents one of the oldest magmatic activity in that region. Most of the earlier research for Ladakh ophiolites have been based on field and analytical approach. The present study has attempted to explore selected ophiolite terrain of Ladakh Himalayas, that is Nidar ophiolite, as using recently acquired hyperspectral data from Prisma mission. The ophiolites at Nidar with characteristic mineralogy and associated weathering at low temperature conditions due to glaciation and formation of serpentine can serve as a potential site that can be studied as good analogues for Martian crust, An investigation of these unique lithology and their alteration product through high-resolution hyperspectral data can help in characterizing these ophiolites for their spectral nature and to understand better the process that are maybe responsible for alteration of the environment on the Earth. Study has utilized data from the Prisma mission. Prisma is a push-broom scanning payload launched by Italian Space Agency in March 2019 and provides hyperspectral panchromatic images of the Earth with revisit time of 29 days. This mission provides data from its hyperspectral imaging spectrometer in form of continuous spectra in range from 400 to 2500 nanometer at 30 meters spatial resolution in 240 spectral channels at spectral resolution of around 10 nanometer and their simultaneous observation by optical camera at 5 meters spatial resolution. The study has utilized Prisma data for the study region available as 30 km by 30 km cloud-free coverage scene. No other hyperspectral data were available from this region, so this was the only data providing an opportunity to investigate the region for first time through hyperspectral data. The data cube were downloaded from ASI's official site. Methodology for data processing included band removal, dimensionality reduction, noise isolation, and extraction of end-member spectra using NV, ArcGIS, and Python programming softwares. The acquired spectra were finally analyzed using resampled spectra from Aster Mineral Library for identification of mineral based on their diagnostic absorption feature in visible and near infrared region range. The results generated from Prisma data for Nidar Ophiolites Ladakh for mineral identification. This is the false color composite of hyperspectral data strip from Prisma sensor with the various lithological section of the Nidar Ophiolite from the Nidar Valley have been represented by these various distinctive colors. The Ophiolite section starts with the melanges section, the tectonic boundary of Ophiolites, followed by ultramafic and gabbroic unit, then they are overlain by volcanics and Kargil formation and Indus formation, which represent the sedimentary sections. And they match well with the geological map of the Nidar section, where these ophiolite melanges are shown by the lowermost boundary, this reddish part, followed by ultramafic in green color, dark green color, followed by mafic gabbroic part in the light green color, overlain by volcanics in red colors, and these Indus and Kargil formation, sedimentary formation in this bluish variants. So this is the false color composite of Prisma data from Nidar section, which well match with the geological map of the Nidar. Section within Nidar ophiolites were interpreted based on spectral response of lithological units from the Nidar ophiolites in different bands. This is the Prisma generated spectral profile of representative spectra from various lithological section of Nidar ophiolites. This is the spectra of ultramafic section. This is the spectra of gabbroic section, followed by volcanic section. And these are the spectra of Kargil formation and Indus formation, the sedimentary formations overlying this ultramafic and mafic bodies. And this is the spectra of Ladakh batholiths, the topmost unit that is following this ophiolite sections. The spectral characterization of ophiolite from hyperspectral, this Prisma data, the dominant mineral from the ultramafic and mafic lithology were recognized on the basis of diagnostic absorption features in visible and near infrared region. The important minerals in these rock assemblages include olivine, pyroxenes, chromite, spinel, and the altered products like serpentine, carbonates, iron oxides, clay minerals, and hydroxides. As observed from these are the Aster library spectra of the various rock that are expected in this region, spectra of granites from patholites, the noritic and this pyroxene spectra, and gabbro spectra having composition of plagioclase feldspar, then altered products in form of serpentine, chlorite, epidote, calcite, dolomite. These are the various minerals and rock spectra from Astor Laboratory that had been utilized for ascertaining the minerals from this Nidar section. High resolution hyperspectral data can improve the discrimination between various lithological units of ophiolites and associated rock, utilizing various image classification and interpretation technique along with spectral characterization based on spectral response of different composition in different wavelength regions. The lithology and dominant mineral assemblage in Nidar ophiolite section shows similarity with Martian crustal lithology. The associated hydrous alteration processes and the serpentinization provide a useful model for understanding the crustal processes occurring over Mars. Investigation of these terrains provides significant clues to assess subsurface habitability condition of the Mars. As the process of serpentinization, which is associated with the formation of the methane that may be responsible for the abiotic or biotic component of the habitability of the depicting the habitability conditions of the Mars. Future work will be focused on comparative analysis of primary and altered lithology of Nidar ophiolites and Neely foci region of the Mars, where such types of rock assemblages representing ophiolite lithology, represented by olivines and serpentines, have been detected on the Mars. The spectral characterization using high-resolution hyperspectral data from Prisma and Prisma is a sensors on board a Mars Reconnaissance Orbiter, which provide hyperspectral data for Martian crust that can help to generate characterization map of primary and altered lithology so as to understand the process responsible for alteration of similar condition on Earth and Mars. To the end of this presentation.